Alright, this morning we're going to learn how to compare the row counts of tables. This is a fairly common task in an environment where you have replication or mirroring. Just to ensure data integrity, a lot of people will do it as a proactive measure to make sure that their data are accurate. So, one quick point to make is that you will run into some peculiarities. There are about 100, well, not 100, there's probably about 20 different ways in which people approach this problem. So I'm going to do one approach because I was troubleshooting some of this yesterday, and you'll see kind of the reason why you don't always get accurate data depending on which method you're approaching. So I have two common table expressions, and you can see the previous video about how to make two common table expressions because this is built off of the same idea. And what I'm looking at doing is I'm looking at comparing bit price in client marketing with bit price in Bitcoin and seeing how many what's the row count of both. And let's just put this down so the whole query can kind of appear. There we go. And you'll see that we're going to go ahead and execute this query. Now, what we find is that there are no data returned. And that's kind of confusing because the first thing was, well, we're looking for a bit price, so we might go to this query and say, is there a bit price? And we see, yeah, there's bit price. And then we go to this table and we say, is there, or I'm sorry, again, we're looking at view. Is there bit price? And we'll scroll down and we won't see a bit price. Well, it's very interesting. If I change the scope, and you can't see this on the video, but if I change the scope to the Bitcoin database, and then I execute this query, all of a sudden bit price shows up. So it's all about scope. Now, again, you can see 100 different ways to solve this problem. I saw someone who used like a loop, and they did a count star from the tables and inserted it into a table. That's great. There's nothing wrong with that. And one of my friends and I yesterday, he's a sysadmin, and we were troubleshooting this, and we tried for each table, which didn't work because the environment we're using, a lot of the code that we can use in other environments doesn't work in the production environment. It was kind of funny. So one of the ways in which we can go ahead and do this is we can just build a temp table. You'll notice here, we're using client marketing. We're inserting basically the same query into the table. The only difference is you'll notice we're adding an where object name ID equals bit price, and we're adding the database name. And then we're going to just basically copy and paste that same query, except now we're just switching it to Bitcoin. And everything else is the same. Then we're going to insert, in fact, well, let's just do it this way. Okay, it doesn't exist. Good. I'm not going to drop the table. And you'll see why in a second. Okay, so that's the result. But let's look at what select star from temp looks like. You'll see it doesn't actually compare things side by side. It just kind of puts them 1 and 2. So what this really does, we're joining the table on itself. And this is a great example of an inner join, because if we look at, okay, this is the result if we select star from the table. If we look at this query, it compares them side by side. You'll notice we're joining the same table on name equals name, but notice we're not joining, in other words, we're saying where it doesn't equal the database. So that's a good example of how you can use a join with a doesn't equal as well, and then you can put it as a row. So basically this becomes something that's side by side. Since bit price is the same thing, now we just want to compare the count of client marketing with the count of Bitcoin. And this is just one approach. Understand this is a good simple approach, especially for people who've seen previous videos, because it kind of builds on things we've already covered. Again, if you were to Google any information, you could find numerous different approaches, but this is actually fairly useful. And in our situation, all of the other different approaches which we were trying first didn't actually work out because the environment we're using, and this is where it all depends on your environment, either it was inaccurate, which is a concern, or the code that we were using didn't function correctly in that environment. So always know your environment, and also make sure that the data you are returning are accurate, because in a report like this, especially in an environment where you have replication and mirroring, it's important to get accurate data, not inaccurate data.